So we can look at the negative exponent by just subtracting the powers here. So we have 3 to the power 5 and 3 to the power 8. So it means we have 8 divides and 3 multiplied. So we're going to take away the divisions from the multiplications, and we end up with this negative exponent. Okay? So basically what the negative exponent means is we have more divides. Or in other words, the negative exponent represents a repeated division. So if I have 3 to the negative 3, so instead of multiplying by 3 times, I'm going to divide by 3 times. Okay? And so any negative power then represents an excess in the denominator or repeated division. So what happens when we have negative exponents with fractions? Well, the negative exponent means to divide. And if I'm dividing a here, well, the a really should go in the denominator. And this b really means, this line here means we're dividing by b, but that negative power means we're dividing again. So divide really means multiply. So we should put it on the top. And if we can simplify our thinking of fractions and exponents as either times on top, divide on bottom, we can make our exponent rules a little bit easier to work with. So if I have this negative 1, really I'm doing the opposite of divide, times and divide. So divide really means the opposite. So then I can do the opposite of this fraction. I could put the times on the bottom, divide on top. And this thinking of times on top, divide on bottom simplify things, because really there's only a top and a bottom. It's what we call binary. It's either got to be times or it's either divide. Okay, it can't be, there's no third option here, so it's either got to go on top or bottom. So if we keep this simple concept, this simple construct, anytime we're dealing with any rational function, we do this as things get more complicated, it's more important that we keep this simple definition of a fraction: times on top, divide on bottom. So as we do these exponent problems, first of all, just remember that if we see pluses in here, we have to be really careful, because plus and powers don't mix. But this is powers and times, and divide, so that's all okay. They are compatible. So really what I'm going to do is I'm just going to try to keep track of my times and divide. What's this? Times 2, divide by a 3 times, and b to the power 0 means that's b to the power 0 really is 1. Okay, so I can put 1 in there, but 1 as a multiplier really just disappears. So really this simplifies to a on 2 on top, a cubed on bottom. And the same thing can be done here. I can make my numerator and denominator. So I'm going to deal with my denominator first. Okay, I know that the power negative 3 means divide. Power negative 2 means divide twice. The numerator is going to be all my multiplication parts. So it's going to be any positive power is times. So I have a cubed b7. Well, if I'm dividing by a 3 times and multiplying by a 3 times, a's really just cancel out. And I can get rid of 2 divides from the times, and I'm just left with b to the power 5.